Hello, Mr. Berry's geometry class. I'm looking at the practice Pythagorean theorem quiz on today, March 2nd. And I want to take a look at the first page that he has listed here on this assignment, which actually I posted yesterday, but I'll review it again. For some reason it was on yesterday's too, so maybe you already have it done. But I'll start with this page. And it started with number 9, and it has a 35-foot wire is secured from the top of a flagpole to a stake in the ground. If the stake is 14 feet from the base of the flagpole, how tall is the flagpole? So here I have, side A, B, and C. Here's the 14-foot away from the flagpole. B is my flagpole. I don't know how tall it is, but this wire from that stake that's 14 feet out to the top of the flagpole is 35 feet. So I want to know what 14 squared is so that I can subtract it from what 35 squared is, because I want to get my B alone. I want to get this variable by itself. I figure out that b squared equals 1029. I take the square root of 1029 to find out what b equals, because I don't want to know what b squared is, I want to know what b equals, and it is 32.08, or 32.1 if you're rounding to the nearest tenths, as we will in the second half of this assignment. For number 11, you may want to pause this as I work forward and go ahead and try the even ones on your own, and just do the best you can on them. So, number 11, we have given the side length to determine whether the triangle is acute, right, obtuse, or not a triangle. So, remember that, let me go back to yesterday's, the rules. If a squared plus b squared is greater than c squared, we have an acute triangle. A squared plus b squared equals c squared, we got a right triangle. And if a squared plus b squared is less than c squared, we have an obtuse triangle. Okay. And just so you know, it might not be a triangle. If the two smaller sides, they must be greater when you add them up. When you add them up, that total must be greater than that third side, that hypotenuse. Okay. So when I add these two up, yes, it's greater than 21, so we got a triangle here. And I take the square roots of those and add them. I get 481. I take the square root of 21, and I get 441. So A and B are greater than C, so we have an acute triangle. These two add up to be more than 26, so we're good. 10 squared plus 24 squared equals 676. 26 squared equals 676. They equal, we have a right triangle. Adding these two up, it's more than the third. It's more than the longer. The two shorter ones are more than the longest one, so that's good. 3 squared plus 16 squared is 265. 17 squared is 289. 289 is greater, so we have an example of an obtuse. So you got an example of acute, right, and obtuse in those three problems right there. Okay, moving on to the second page for his review, or the practice Pythagorean theorem quiz. Remember, we're dealing with a squared plus b squared equals c squared when we're finding the values of these, okay, because we see that these are all right triangles, so they're going to be equal to each other. So I have 7 squared plus 10 squared, and I find out that 7 squared plus 10 squared is 149. I take the square root of these, so you got to square root these, and you'll get 12.2. How do you do square roots? Okay, let's do this one on the calculator, just in case you need it. I never know what's going on at home and if you're able to do this or not. So I have 7 squared plus 10 squared, and that's going to be equal to 149. So I want to take the square root of that 149. I'm going to hit second, and I'm going to hit this button right here, the x squared. You see that little square root there? That's what we're doing. So second gives me whatever operation is above the button. And I'm going to go with 149. You don't have to hit the back parentheses, or you can. It's up to you. You'll get the same answer. And that's how I got the 12.2. Rounding to the nearest tenths, the direction said. So there's a 0 after that 2, so that 2 stays the same. So it's 12.2. Taking a look at number 3, I have 16.2 plus x squared equals 27 squared. I have to solve for, this would be side B, in other words, but I'm calling it x right now because it is named x. So I figure out that 16 squared is 256 and 27 squared is 729. I subtract 256 from both sides. I take the square root of 473 and I get x equals 21.7. For these two, I only want this part, this half of 18. So that half of 18 is going to be 9. That's how I figure that, this half was 9, this half was 9, okay? So I'm going to take 9 squared plus 20 squared. That's going to equal x squared. And I take the square root of 481, which is the sum of 9 squared plus 20 squared, and I get 21.9. Number 7 takes a couple steps because, I want to find this over here, but I need to know this, and I need to know this. So how I am going to know the dotted line here? I'm going to take 16 squared plus b squared equals 22 squared because this is a hypotenuse. If this is a right angle, this is going to be a right angle over on this side too. So in solving that problem to get b, I figure out that b is 15.1, and you see my operations there. So now this is 15.1, so this is 15.1, and I need to know what this is. I figured out what this was by just taking 44 minus 16 to see what's left over, which it ends up being 28. So we have 15.1 squared plus 28 squared is going to equal x squared, and I have that written over here. Ends up being 1009. I take the square root of 1009 and I get 31.8. That's my measurement for x, rounded to the nearest 10. Hopefully this is a good review for you and get you ready for that Pythagorean theorem quiz. I believe the quiz is going to be on Friday.